How could superconductivity change our electricity? Imagine a world where your electricity flows without losing any energy along the way. That's what superconductivity promises to do. It's like having a superhighway for electricity that never slows down or wastes fuel. Right now, when electricity travels through wires, some of it turns into heat because of resistance. Resistance is like friction for electricity, and it causes energy to be lost. That's why power lines heat up and why we need to generate more electricity than we actually use. Superconductors are special materials that, when cooled to very low temperatures, carry electricity with zero resistance. This means no energy is lost as heat, making the whole system much more efficient. If we could use superconductors everywhere, we could cut down on wasted energy and lower electricity bills. Power lines could stretch across long distances without losing power, so we could send electricity from remote solar farms or wind turbines directly to cities without wasting much. This would also make it easier to build larger and more powerful electrical grids. Superconductors can carry much higher currents than regular wires, so we could transmit more electricity without needing bigger or more wires. This is especially helpful in crowded cities where space is limited. Superconducting materials are already used in some medical machines, like magnetic resonance imaging scanners, which need powerful magnetic fields without generating heat. In the future, superconducting motors and generators could be smaller, lighter, and more efficient, helping to make electric vehicles and power plants greener. Superconducting cables and transformers could also be safer and more environmentally friendly. Unlike traditional transformers that use flammable oils for cooling, superconducting ones could use liquid nitrogen, which is safe and cheap. This could allow us to put electrical equipment in places where it's too risky now. Superconductivity also makes magnetic levitation trains possible. These trains float above tracks using superconducting magnets, which means less friction and less energy needed to move fast. One of the most exciting possibilities is in fusion energy. Fusion reactors need very strong magnetic fields to contain super-hot plasma. Superconducting magnets can produce these fields efficiently, bringing us closer to a clean, nearly unlimited energy source. The main challenge is that most superconductors need extremely cold temperatures, close to absolute zero, which makes cooling expensive. But scientists are working on new materials that might become superconducting at higher temperatures, making them easier and cheaper to use. If that happens, superconductivity could revolutionize how we generate, transmit, and use electricity, making our energy systems more efficient, cleaner, and more reliable. This change could lower costs, reduce pollution, and help us move toward a more sustainable future.